Hello everyone, this is Kumo Nina. Nina is a math gal with a math life. Do you know you can solve simultaneous equations by doing this? X is 3 times minus 2 minus 5 times 9 over 6 times minus 2 minus 5 times 3, which is 17 over 9. Y is 3 times 3 minus 6 times 9 over 5 times 3 minus 6 times minus 2, which is minus 5 over 3. Why does this method work? In this video, I'm going to prove it and also introduce other methods to solve a system of linear equations. In the previous math video, we introduced a method that was used in Mesopotamia. If you haven't watched that video yet, please follow the link, which is there, or in the description below. In this video, we are going to talk about modern methods. Now let's start the proof. We take two linear equations with arbitrary coefficients. Ax plus by equals c, dx plus ey equals f. Here we use the elimination method. Firstly, we need to make the coefficients of y equal, so we multiply the first equation by e and get aex plus by equals ce. If we multiply the second equation by b, then bdx plus by equals bf. Now we can subtract equation 3 and equation 4 so that y gets eliminated. And so, ae minus bd times x equals ce minus bf. Therefore, x is ce minus bf over ae minus bd. If we remove x, we get a formula for y. We multiply the first equation by d and get adx plus bdy equals cd. Multiply the second equation by a and get adx plus aey equals af. Equation 5 minus equation 6, we obtain bd minus ae times y equals cd minus af. Thus, y is cd minus af over bd minus ae. If we put these two formulas next to the original equations, we can see that x is this times that minus this times this over this times that minus this times this. Similarly, we can draw some lines for y. We call this method the cross multiplication method. Do we have other methods to solve simultaneous equations? Of course we do. In the next few minutes, I'm going to introduce 5 methods. When we derive the formulas for the cross multiplication method, we use the elimination method. In the elimination method, we add or subtract two equations to get a new equation in one variable. There is another method called substitution. We use the substitution method when the coefficient of x or y is 1 or minus 1. For example, 3x minus y equals 2, 2x plus 3y equals 5. We can change the first equation into y equals 3x minus 2 and substitute it into the second equation to get 2x plus 3 times 3x minus 2 equals 5. This is an equation with only one variable, so we can easily find the answer. Once we find the value of x, we need to substitute it into the third equation to find the value of y. The elimination and substitution methods are very similar because we need to get rid of one of the variables and then solve a linear equation in only one variable. Next, we will talk about the graphical method. We first sketch the graphs of these two equations. Since there is a unique line passing through two distinct points, we only need to find 2 points on each line, and they are x-intercept and the y-intercept of the linear equation. Let us look at these two equations. X minus y equals 2, 2x plus y equals 2. The x-intercept of the first equation is 2, 0, and the y-intercept is 0 minus 2. For the second equation, the x-intercept is 1, 0, and the y-intercept is 0, 2. We link these 2 points and get 2 straight lines. These lines meet at one point. The intersection points gives us a solution to the system of linear equations. We need to read the coordinates from the graph. They will be approximate values. If the solutions are integers, they should be fine. But if the solutions are decimals, it will be very difficult to get accurate answers. Also, we can only use this method to solve simultaneous equations in two variables. It's easy for us to draw a 2D diagram, but it will be hard for us to draw a graph in a higher dimension. Now we will look into two methods involving matrices. For the first one, we will use inverse matrices. If we have AX equals B, we can multiply both sides by A inverse and get A inverse AX equals A inverse B. A inverse A gives us the identity matrix I. So, X is A inverse B. Let's again look at this system. 6x plus 5y equals 3. 3x minus 2y equals 9. We first rewrite this system in matrix form. This matrix, 6, 5, 3 minus 2, is called a coefficient matrix. Let A be this matrix. Let's first find the inverse matrix. A inverse. It's equal to 1 over 6 times minus 2 minus 5 times 3 times the matrix minus 2 minus 5 minus 3, 6. And then we get the matrix 2 over 27, 5 over 27, a ninth, minus 2 ninths. We can get the solution by multiplying this matrix with the matrix 3, 9. Then we get 17 over 9 minus 5 over 3. The first entry of this matrix is the value of x, and the second entry is the y value. Finally, we introduce the method using reduced row echelon form, a matrix in reduced row echelon form. If the leading entry in the first row is 1, the other row also starts with 1, but it's to the right of the leading entry of every row above. The leading entry is the only non-zero entry in its column. All zeros are at the bottom. We will still look at this system. We rewrite the whole system into one matrix. We can draw a line here to separate the left-hand side and right-hand side of these equations. To change this matrix into reduced row echelon form, we need to do some row operations. The required form is here. The last column gives us the values of x and y. The valid row operations are swapping rows, multiplying or dividing a row by a non-zero number, adding or subtracting a row and the product of a row and a non-zero number. So, the first row operation we can apply here is to change the second row into 2 times row 2 minus row 1, and then we get 6, 5, 3, 0, minus 9, 15. Next, we change the new second row into row 2 divided by minus 9. So, 6, 5, 3, 0, 1, minus 5 over 3. Then we change the first row into row 1 minus 5 times row 2 and get 6, 0, 34 over 3, 0, 1, minus 5 over 3. Finally, we change the first row into row 1 divided by 6. So, 1, 0, 17 over 9, 0, 1, minus 5 over 3. Now we get the answer. X is 17 over 9 and y is minus 5 over 3. This method is a bit long, but we can use it to solve a system involving 4 variables or even more. What do you think about these methods? In this video, we introduced 6 methods in total. Which one is your favorite? Well, I hope you enjoyed this video. Thanks for watching. I will see you in the next video.